Hi everyone, my name is Roy Osherove, and this is a short video that I'm doing about writing complex logic with complex business rules using test-driven development. The reason I'm doing this video is, first of all, so that I don't forget, and second, so that I can show it to students of mine during courses that I teach. And you can find out more about me by going to my blog at icrealizable.com. And this is also going to be part of my book, which is called The Art of Unit Testing. And this is an upcoming Manning publication, which should be up in about, I don't know, 5 to 10 years. In any case, you will soon be able to download that book online through Manning.com. And if you want to know more or get notifications or even just download the first chapter of the book right now, you can go to the.artofunittesting.com and download that chapter and get notifications. Now, the type of scenario that I'm speaking about right now is a very basic, run-of-the-mill validation constraint logic type of scenario. It's those kinds of scenarios where you have many rules and you have this big, maybe function that checks all these rules and combines them. And if, depending on some involved logic, it returns true or false or does something. Um, and a lot of times this is part of validation process in many applications. So the canonical example that I can think of is password validation function, which returns true or false if something is valid or not. And there, you can have a lot of rules for password validation. For example, a minimum number of characters, to have digits, and so on and so on. Now, of course, you can use maybe some regular expressions to test these kinds of things, but sometimes regular expressions are just for testing the text. What if your application needs to test something that is not pattern-based? You want to make sure that this is done as well. So you want to make sure that all this logic works. So there are different challenges to testing this kind of function. First of all, you need to understand that there are two kinds of tests that you need to write for this sort of logic. The first of all is that you need to test the individual logical constraints. For example, you want to know that if there are maximum number of characters that are exceeded, you want to know that something failed. So you probably would write a separate function and test it out that receives an input and returns true or false whether it passes or not. So you would probably write a different function for each rule. And then there is the one layer above, which is the logic that uses all these small constraints and combines them to give one single result. So that's the logic that has all the if statements and it says, well, if there are a maximum number of characters or there aren't any of these and this is not true, then do something else. Now, the main challenge is that once you know how to test these kinds of constraints is to write it in test-driven development. So I'm going to show a demo of how you can actually write in a test-driven manner this kind of logic using tests that fail first. So here's an example of the validate function on a class, and this is the hierarchy of how the validate function will work. This is how I want it to look, or this is what I have in my mind when I think about it. So you'll notice that in the upper part here, the validate function is merely using all these small functions underneath. Now each of one of these methods or functions is a rule on its own. It does a very simple thing and it has its own logic. And this is the complex logic that I would like to test. However, I want to make sure that it's tested and I'm writing it in a test-driven manner. So if I spoke earlier about the two kinds of tests, you'll note that I basically am going to write a test or many tests for the validate function and its logic, but I'm going to write separate tests for the has at least 6 characters and so on and so on. And the tests here are going to pass or fail independently of the tests here. So even if it has at least 6 characters, its tests are going to fail. The validate function, its own tests might still pass because the logic here still works. So this is basically uh, not very much different than separating dependencies uh, in a regular TDD application, TDD written application. Just imagine that this is actually a web service call. So even if the web service doesn't work, I still want to make sure that my interaction with the web service here still works. So this should pass even if this fails. And how do I do this? Well, usually the what happens is that the pattern in the code has to look similar to this. The code uses all these functions, and the functions returns true or false. And combining these values uh, during the test and telling those functions what to return can actually make us test validate separately. So here's an example. We are going to write a test that uses validate, but it sets up the sub-methods here to return the values that the test would like to return. So in our test, the scenario would be if the password does not have a digit inside it, that is, this method returns false. And even though all these other methods return true, the validate method will return false to the test. Now this is interesting because if you write test-driven development, you might not actually have this method or this method or this method. You might just have this method to test on. But you still want to make sure that in the next tests, the previous test is still going to pass. So this will probably make more sense once we get into the code. But we are going to go through this scenario and use test-driven development to write it. Now, to understand that, we need to understand a very powerful technique that we're going to use during our testing so that we can actually control these values. And there has to be some way to control these values that our test says, well, this will return true and this will return false. And why do I want to control these values from my test? I mean, why shouldn't my test just give an input to validate that passes this but does not pass this? Well, the answer is that sometimes the input to validate by the end of the production code is going to be very, very complicated. Just imagine that some of the requirements here may be very, very powerful, such as uh, the inputs have to be defined in a certain way, have to be of a certain size, and so on and so on. So I would want to control them even though I don't want to actually run this code. I just want to simulate the fact that hasDigit returns false. So my test needs to simulate that. And to do that, our test is going to have to create a class that inherits from the class that contains all of this. So if I'm going to actually uh, use some drawing tools here, so if we have a class here, so let's continue. So the technique is called extract and override. If you're interested in learning more, there's a great book called Working Effectively with Legacy Code by Michael Feathers, and there he explains this. But this is also called the Test Specific Subclass pattern if you read the X Unit Test Patterns book, which just came out. So the technique basically says that we're going to create a subclass of the class under test, and then override each of these functions and return whatever values we want. So let's see a demo of that and then continue. we're in Visual Studio, and I just want to show you a picture of my son, Itama, which is born December 28th, 2006, and I love him very much. So now he's in the video. In any case, here's my code for the book The Art of Unit Testing, and this is everything I have right now. And I'm going to use this solution to show the idea of extract and override and the test specific subclass. So let's add a class that is depending on time so that we can test it and see how we can test it. Let's call it my time-based class. Okay. I'm going to also use a program called Keyboard Jedi. And the idea about Keyboard Jedi is that it will show any keyboard shortcuts that I'm using inside Visual Studio. I'm also going to use ReSharper so that if you see me doing something like this, you can see that I clicked Alt plus Enter to show the menu that you're seeing right now. So this is part of ReSharper. I'm just going to optimize the usings here. Let's do a public class, and I'm going to write one simple method called public string get current time to see that it's actually get current time in, well, let's just say that my method is going to be like this. So the method I want to write is a method that maybe is used for backup, and so the method should tell me if a week has passed since the last backup. So let's write a property. Let's write a field. Let's say date, time. Now the date time is, we're going to use system date time to say last backup. And let's create a property. That's the last backup. And let's also do something like public bool should back up now. Let's return false. Well, let's return date time. Let's date time dot now subtract last backup is in days is bigger than 7. So if more than 7 days have passed since the last backup, it should return true. Now, how can I test this method? So let's try to write a test for this method. Let's add a new class. Let's call it, and since this class is called my time-based class, let's call it my time-based class tests. Now this is a test class, so it's going to be public and test fixture, and let's write a test here. Now in my test I'm going to write 3 parts. The first part is going to be the method that I'm testing. So should backup now is the name of the method that I'm testing. The scenario is less than 7 days away. Returns false is what I'm expecting. Okay, so how can I test this? So the first thing I'm going to do is I'm going to refactor the class because I don't want my test to have to wait 7 days. So I'm going to actually write a new class here called testable my time-based class, which inherits from my time-based class. Now, the reason I'm doing this is so that I can overwrite some stuff. But what do I overwrite? First, I'm going to get the current date time and convert that into a method call. So get time now, and let's make it protected. And make it virtual. That way we can override that in the class, in the testable class. So what I'm going to do now, I'm just going to override my get time now and say return current time. Now what's current time? It's going to be a field called current time. Let's make it public. What else? So now I can use my actual testable time-based class, uh, backup equals new testable time-based class. Now I'm going to tell backup that the current time equals new date time. The year is 2000. The month is 1. The day is 1. That's okay. Now the thing is, since this overrides the behavior, and actually in the X-Unit Test Patterns book, this is a variation of the pattern. It's called Behavior Modifying Subclass, which is pretty smart. What we're going to do is, in the test, we just told it what the time is. And now we're going to say backup should backup now. Okay? And let's make it into a variable. Result, or let's call it should backup now. And I'm going to assert is true on the backup now. So let's see. Here's a test that should actually say, well, okay, this is wrong because my test actually says has to be less than 7 days, so it has to be is false. And the new date time is okay, so we have to tell the backup here. Backup. Less backup equals new date time. And let's say 2001 and 1. And the current time will be 2001 and 5. So backup now should actually return false. Okay? So last backup is a standard property. So you can see that in the production code, we would actually be using the real date time. But in the tests, we're actually getting the time that is under the control of our test. So this is called behavior modifying subclass. By overriding the method, I just changed the behavior of the class under test. Therefore, I can override time. I can make time stand still, and my test will always run. Let's write the opposite test and see that it actually works. Should back up now. More than 7 days array returns true. So let's say 8, or actually 9. This should be is true. Let's run all of these, and this is actually an add-in called tester in .NET that I'm using, and I'm running it here. You see 2 tests have passed. And that's it for now. Let's go back and actually see how we can use this technique to catch complex validation logic. So that was the demo. Let's take a look at what we're going to do now that we know about extract and override. So we're going to write a password validator class that has all these complex rules. And we're going to write a test that uses the validate, and it's going to have various virtual methods that we're going to use, and we're going to actually override these virtual methods in our test and do it in a test-driven manner. So let's see what that looks like right now. So let's write our validator from scratch. So I'm going to actually write a class called validator, but my first test is actually going to be on a method called isValid that takes a password. Now, I'm actually testing it on the logical level, the one that uses the rules. I'm not testing the actual rules right now, just the fact that the rules are being used correctly. And that means that I'm checking is valid when rule, which is called at least 6 characters, is false, then it should return false. That means all the other rules return true. So what am I starting with? I'm going to start with an actual testable validator class. Testable validator tv equals new testable validator. And I'm going to make it compile soon. But let's finish the test first. TV, and I'm going to say set all flags to true. Oops, I set all rules to pass, which is my way of saying I'm only testing one rule right now. And we'll see that it's a very simple concept. Next, I'm going to say tv.flag at least 6 characters is actually false. So that rule is not passing. All the other ones are. And the next thing I'm going to do, I'm going to say bool is valid equals tv.isValid. Some meaningless text as password. Now, this is actually meaningless text as password because I'm not actually testing that it's using the string here. I'm testing that it's calling the underlying rules. The string right now is meaningless. Some meaningless. And I'm asserting that something is false, and that would be the isValid method. So I'm pretty sure that when you're looking at tests right now, this seems very, very weird to you, because there is nothing here that makes much sense. But this is the way we're testing the logic. This is the way we generate it in test-driven manner. A testable validator is a validator that allows us to muck around with the behavior. And what are we doing with the behavior? We're saying, well, all rules are going to pass internally besides this rule. Now, when that's true, when all this is true, but this is false, the isValid should actually return false. So let's make this happen. Let's generate the testable validator class. And that's actually going to inherit from a validator class, which is not existing right now. So let's create a class, and this class is going to be our production code. So this is our test specific subclass, and this is the class that we're actually testing. Now, let's turn our attention to this interesting method, which right now does not do anything. So let's create a field called flag list 6 characters. And now this method will actually set all the flags. Right now we only have one. Flag list 6 characters is actually true. Whenever we add more fields like this, we're going to add a row here that sets that flag to true. And you can definitely write a simple reflection related method that loops through all the fields, and whatever starts with flag it sets to true. Now the only thing left is to actually implement the isValid method. And the isValid method is actually going to be generated on the testable validator class. We are going to move it quickly into a let's see, I'm going to refactor it quickly and say that we're going to move it up into the base class. So this is valid here. So now isValid is part of the validator class, and obviously it throws an exception. Now, where does this flag take place? Well, to do that, we need to implement the business rule here. So I'm going to do it test driven, and the way I'm going to do it is going to say override, and I'm going to override a method that doesn't exist yet, and that method is going to be has at least 6 characters that takes a password string. Override bool. Now the interesting thing is that I'm going to create the method in the base class, and it's going to be generated as a private virtual method. So let's just make it that override into a protected method. Now, what we're going to do is actually say return flag of at least 6 characters. So what do we have so far? We generated a production class that has an isValid method and has an at least 6 characters method. And they both throw an exception. Now we're going to write a test for this one separately. Right now we're testing this method, and our test is going to prove that this method is not calling this one. How do we know? Because we're actually testing this class, which inherits from this one. And in this class, we override the has at least characters method and say that this one returns false. And if this one returns false, then in the production code, this one should not throw an exception, it should just return false. I hope that makes sense. Let's run the test and see what happens. And obviously I get an exception. The method or operation is not implemented. So let's make the code pass as simply as possible. And to do that, let's just say return false. Now, if I run on the test, obviously it will pass, which is weird. So let's do another test. I'm going to duplicate this code and say, well, is valid when rule is actually true, returns true. So this one is actually true. And I'm asserting that this is true. Let's run all the tests. And obviously my test will fail. Expected true, but was false. I can see here, this is why it failed. So let's make the code actually use the production method here. So return has at least 6 characters. Null. Why does that matter? Well, this is a problem. We're going to need to prove that I'm actually going to have to send in the actual password. But as you can see, the 2 tests are now passing. So let's add another rule. Things should get pretty simple from here. The first rule I'm going to add is to say test is valid when rule uh, has no spaces is false. Returns false. So testable, you know what, let's just make this into a setup method. So I'm going to actually say resharper, refactor, and convert. Oh, never mind that. Let's say here setup public void setup and I'm going to say this here validate TV equals new testable validator. So now we have TV here, and now let's use this. TV set all rules to pass. Now TV flag has no spaces equals false, right? And TV is valid. Null doesn't really matter. Assert is false on valid. So when flag has no spaces, false. The TV should turn testable validator should turn false. So let's generate this field, and flag has no spaces is also true here. And I'm going to override another method. Override bool has no spaces. Return flag has no spaces. Let's generate this method. Create method in base class. Let's run all the tests. Bam. Expected false, but was true. Interesting. So what does that mean? It means that all we have to do is add this call here, and has no spaces. Null. If we run the test right now, they should all pass. So what happens if we want to test a rule that says one is true and the other is false? then throw an exception. Well, we obviously don't need to test the other rule, the says when this is true, because we already have something that says test when everything is true and everything passes. So now what we want to do, let's say that we need to add another rule, and this one is going to be is valid when rule, let's say, has the letter A as false, and rule has no spaces is false, then it should return true. Why? I don't know why. That's that's just a rule that I just made up. So if it doesn't have the letter A, but it also doesn't have any spaces, it's okay. So let's see. This one is good, and flag has the letter A is false. Then valid should be true. Let's create a field here, and flag has the letter A is true here. Now let's override something else. Has the letter A. Return flag has the letter A. Let's implement this. Done. Notice nothing here happens. Now I need to add this test here. I'm running the tests. Obviously this test fails. So now I need to add my new logic here. So the logic that I need to add should be here. If has no spaces and has the letter A, null. If not has no spaces, so if it has a space but it doesn't have the letter A, it should return true. Return true. I hope I did that right, because now it's starting to confuse. Let's see by running the tests. Bam! And they all pass, which is interesting. So now even if I change this to from true to false, all my tests should pass, even though the logic is horribly flawed. I mean, it's not flawed. I mean, the implementation is not there. Now I can actually let another team write the implementation here. For example, some special algorithms team. So let's try to write a test for the method here. Has at least 6 characters. And how do I do that? Well, how do I get access to this? Well, I can actually inherit in my class from testable validator. And another thing that I can do is I can actually use the attribute of friend attribute. What was the name of that? Internals visible to attribute. So I can actually say internals visible to attribute as a type of assembly attribute here, and just put in the name of an assembly. And if that assembly is a test assembly, it can still look at the protected members, or the internal members, I'm sorry. Now, the last thing that I want to do, I'm actually going to move the validator to another file, and then I can actually start testing stuff here. So let's add a test. Now notice the difference in the name. The difference is has no spaces. That's the method I'm testing. That's the difference. Has a space, returns false. So string password equals space. Okay, because that's the simplest thing I can think of. Validator v equals new validator. V, this is interesting. How do I get access to that? Well, I should say internals visible too. So I'm actually going to go to V here and say protected internal. Protected internal, internal, internal. And I'm going to say V, and you can see that I can see it now here. Now, if this was a different assembly, all I had to do is to put that internals visible to and put the name of my test assembly in there, and I would get the same list. As it looks, has no spaces. Let's give it the password. Let's get the result. And assert is false. Has no spaces. Now if I run my test, sorry, and of course this is missing. Let's run my tests again. And of course my test has failed. And it's failed because has no spaces throws an exception. So all I have to do is say return password contains space. Obviously this could have been much more interesting if the algorithm was more interesting. Bam, all the tests have passed. So that way I'm testing the actual algorithms and the logic that uses them separately. Now, by now, you should probably be aware that there is, it can get more complicated than that, but these are the basic steps that you can do to get this thing rolling. So thank you for your time. I hope you stop by and check out my book. Thank you very much. Cheers.